Hey everyone, and welcome to EENG 363 Analog Devices. So in this first video, I want to just kind of give a brief introduction and some motivation as to why we want to look at several of the items that we're going to look at throughout the semester. So the first thing I want to point out is you'll notice that the title of the textbook we're using is Microelectronics, yet the title of our course is Analog Devices. And so often similar courses will be labeled as electronics or microelectronics, and I just want to mention why that is briefly. So typically microelectronics is going to refer to IC technology, and so by IC, of course, I mean integrated circuits. So that's something that we've talked about briefly in a previous class. And so our integrated circuits are just those, we can think of them as sort of our small microchips that have sort of everything that we need on a circuit in a single package. And so with this integrated circuit technology, with sort of our state-of-the-art manufacturing, we can fit billions, with a B, of components on a single piece of semiconductor. And so we're going to talk a little bit later on what these components are. Primarily, they're going to be something called transistors, but we can have billions of these components on a single piece of semiconductor. And so we'll talk about what exactly is a semiconductor, why is that useful. That's going to actually be the first thing we talk about. But the basic idea is that for microelectronics, we have these relatively small packages that have billions of components that sort of we can make our circuits from. In this class, we're going to focus more on discrete circuits, however. So for this class, we're going to focus on discrete circuits. And so for discrete circuits, what we can think about is that's something we can go into the lab and we can say, I want this component, we can pull these components off the shelf and we can sort of assemble the circuits ourselves. They're not all packaged together in one sort of chip like an IC would be. And so what we're going to do though is that this focus on discrete circuits is going to help us build an understanding of IC circuits. So help build understanding of IC circuits. And so a lot of the times throughout the class and into our future classes as well, I'll talk about certain design ideas and techniques that we need to keep in mind if we are going to be working with integrated circuits. But of course, most of our lab work and a lot of the stuff you'll see is going to be these discrete circuits where we're just pulling individual components, putting them together, in our case on our breadboard, in order to make whatever circuit we want. So in general, if we take a step back, we can talk about electronic circuits. So most electronic circuits are going to have two inputs. So let's say our electronic circuits, so now we're not even limiting this to microelectronics, we're just saying electronic circuits in general are going to have two inputs. So the first input is going to be our DC power supply. And so we're going to be inputting this to what I've labeled generally here as an amplifier circuit. So we've got DC power here. Our second type of input is going to be some time varying signal. And so this is, of course, what we're going to be wanting to amplify. So we also have this going into our amplifier. And so now we have our amplifier, which is going to be outputting the signal to some load. So the example that it gives in your textbook, for our signal source, maybe we have some type of music player, so it's a little outdated, so they say a CD player, but some other type of music player as well. And so that's going to send a low power signal to the amplifier. Our amplifier, of course, is going to, with the help of this DC power supply, make that signal higher, have more power, so we're going to have a high power signal, which is being sent to our load. And so of course if we have some type of music, maybe our load is going to be a speaker which is able to play that music at a louder volume. So what we're going to focus on is of course these amplifiers. We're going to look at a few things first, but ultimately we're going to get to, as I mentioned before, something called transistors. And naturally what we're going to have to do is we're going to have to consider two types of analysis. We're going to have to consider an analysis due to this DC power supply input. And we're also going to have to consider the analysis when we input this time varying signal. So for each stage, for each type of transistor we're going to look at, we're kind of going to look at two sort of different ways to analyze it depending on which of those two inputs we're considering. And then of course we can just combine those using superposition. One other thing I want to mention in this brief introduction video is a summary of the notation in the textbook. And so I'll mention this again when it's relevant, but I want to have it up here up front as well, just so that hopefully we're all on the same page. And I'm going to do my best to stick to this notation, but if you ever notice me deviating from it, please let me know, and I'll try to update the notes to match our textbook notation. So the notation is going to be relevant depending on whether we're talking about AC or DC signals. So of course we're dealing with time varying, which is going to be AC, DC signals for our power. So we want to make sure we're not getting mixed up between the two. So the first one is if we have a combination of AC and DC, we're going to have a lowercase variable with an uppercase subscript, so I sub b, for instance. And if we have a voltage, maybe we have lowercase v, uppercase be. And so what this represents is total instantaneous value. And so that would be AC and DC together. Now if we just had the DC values, we would just have capital parameter, capital subscript. So I sub b, capital V, capital BE, for instance. So this is just our DC values. Now if we had just our AC values, we're going to do both lowercase. So we'd have lowercase I, lowercase b, lowercase v, lowercase b, lowercase b, and lowercase e, it should be. And so that's going to be our total instantaneous AC values. Okay, and I noticed I've misspelled instantaneous up here. Let me just fix that real quick. Instantaneous. Okay, and then of course the final one is if we have an uppercase parameter and a lowercase subscript, so I sub b or capital V, lowercase b sub e, and what that's going to represent is phasor values. And so again, before we get to this in the text, I'll try to point that out just as a reminder, but I want to go ahead and share that with you guys up front. So what we're going to do in our first section is we're going to start by looking at semiconductor physics. So remember, semiconductors are what these integrated circuits are based on, and we're going to use that as sort of that understanding of semiconductors to build our understanding of these more complex devices.